So in this video, we're going to talk about inverse matrices. And okay, so before we can really talk about inverse matrices, we need to talk about the identity matrix. So I just want to kind of establish the pattern with you first. So this is the 2 by 2 identity matrix. So I just want to point out ones down the diagonal, zeros everywhere else. So if I now go to the 3 by 3 identity matrix, so I want you just to notice again, ones down the diagonal, zeros everywhere else. So this is what's known as the identity, and we can have an identity matrix as big as we want. We just continue the pattern. So if I have this n by n, fill in whatever number you want, general identity matrix, you're going to have ones down the diagonal and zeros literally everywhere else. And so the identity matrix actually has, it's pretty important. So let me show you what is important about it. So let's say that I have this matrix A. So, okay, if I want to multiply A times I, first of all, I is what indicates that we have the identity matrix. So whenever you see the I, or sometimes you might see like I and then like a little subscript like this, like I sub 3. So this in the land of matrices always means identity matrix. So if I wanted to multiply these together, okay, so let's say that I've got this 3, 2, 1, 8, 1, 7, 3, 1, 0. Okay, so the identity matrix, we just know what that is. So it's going to look like this. Okay, so let's go ahead and multiply these together. So if I do this, let's see, where can I get some space? Actually, I will clear some space. Okay, so if I multiply these together, so I'm going to have this row times this column, so that's just going to leave me with 3, right? Because I'm going to have 3 times 1, and then the rest is 2 times 0, 1 times 0, so it just leaves me with 3. So next, now I'm going to take this row times this column. So the 3 will drop out. I just have the 2 times the 1, so this becomes 3, 2, okay? 3, 2, 1 times this. What am I left with? Just the 1 times the 1. Okay, so what I want you to do is I want you to finish this calculation. So I did the first row for you. You finish it on your own, and then hit play when you think you've got it, and then I'll finish it on my end. Okay, so so I've got this row times this column, so it's going to be 8. This row times this column just leaves me with the 1. This row times this column will just leave me with the 7. And then for the last row, you should have gotten 3, 1, and 0. Okay, and so this is what makes the identity matrix what it is. When you multiply a matrix by the identity matrix, you just get back to your original matrix. So that is what is important about the identity matrix. And so let's just do a little experiment here. So what if I took that same matrix A and now I wanted to do I times A, so the identity matrix times A. So once again, I want you to pause the video here. I want you to take a second to explore this on your own. Math is not a spectator sport. Give that a try. Hit play when you're ready. Okay, so I'm multiplying these two things together. And so through your calculations, let me clear some space again. Okay, so as I repeat this calculation, so I've got this row times this row, so that's going to leave me with 3. Then this row times this column, which leaves me with 2. And then this row times this column, which will leave me with 1. And as you continue this calculation, you should have found the exact same matrix again. So again, that's the point of the identity matrix. So this exercise, the point of it was to get you to trust the identity matrix. So when we see it, we just automatically know that that's what's going to happen. And we've just proved it to ourselves. Now, normally, multiplication with matrices is not commutative, right? But the identity matrix is commutative with square matrices. So I have A times I is going to be equal to I times A. So this is just a unique matrix where we do actually have commutativity, and that's kind of important. Okay, so now that we've talked about the identity, now we can talk about inverses. The identity and the inverse kind of go hand in hand. Now, believe it or not, you've always had inverses in your life with numbers. You just maybe weren't aware of it. So with real numbers, we have this property. A times 1 over A. So if you take A and then multiply by its reciprocal, you will get to 1. We know this. And okay, so here's the deal. This idea here that I can multiply by the reciprocal, this is what's known as a multiplicative inverse. And what makes a multiplicative inverse is that it gets you back to the identity element. And again, this might have been something you weren't aware of, but with real numbers, the identity element is 1. So when we talk about multiplicative identities, it's this like concept of some number or numbers or things or whatever that when you multiply them together, you wouldn't change the value. So if I can multiply two things together and get 1, that gets me back to the identity. So 1 is the identity with real numbers. And I just want to throw this out there. This 1 over a, so you might remember we can also rewrite this as a to the negative 1. So this also, this a to the negative 1 actually doubles as inverse notation. So we can write 1 over a or a to the negative 1, but we also know that these are just inherently inverses. That's always kind of been in the background. Okay, so I bring that up because some matrices have multiplicative inverses. Not all matrices, but some do. And we'll learn how to figure out which ones do and which ones don't. Now, if A is a matrix, then its inverse is denoted with similar notation, a to the negative 1. But this doesn't mean in the land of matrices, this doesn't mean this is an exponent. This means inverse. So when you talk about real numbers, this can work as a negative, this can work as an exponent. When you talk about matrices, this is actually standing for a concept. So it's a very important shift in how we view the notation. And so with matrices, when two matrices are inverses, if you multiply them together, you get back to the identity matrix. That's what makes two matrices inverses. So you can always test if two matrices are inverses by just multiplying them together and seeing if you get to the inverse. And we will play around with this in a few moments. And right, so just remember the I stands for identity matrix. The N can stand for the size. I think some books will have the N, some books might not have the N. So I just kind of wanted to remind you of that. Okay, so how do you find an inverse of a matrix? So this is actually a multi-step process. So to find a matrix's inverse, first you're going to set up an augmented matrix. So you might remember this from working with systems, but this is a different type of augmented matrix. You augment it with its associated identity matrix. So this is going to be a massive matrix, and we'll go through this in an example in a second. And that just the general strategy, just to kind of tell you what we're going to do, is you're going to perform row operations so that this side that has the A, we want to see if we can perform row operations to get it to look like an identity matrix. And in doing that, the other side is going to transform into the inverse matrix. So it's kind of a cool little process. And this B here, this is going to be our inverse matrix. So this is the overview of what I'm going to show you. So I just want you to kind of understand like what is the point of what I'm trying to do. So let's try to find these inverses if possible. Okay, so I'm going to start with this 2x2 matrix. This will be the easiest one to start with. And okay, so remember, the name of the game here is we create this augmented matrix. So what I'm going to do is I'm going to take this matrix, okay, and I'm going to augment it with its associated identity matrix. So here's the augmented matrix, all right? Okay, so now what we're going to do is we're basically just going to like use Gauss-Jordan, like the whole Gauss-Jordan method on this side. And this side's going to come along for the ride, and then you'll kind of see what happens. So let me clear a little space. Okay, so first things first, I would like to get a 1 here, right? And in thinking about this, so I think the easiest way to do this actually would be to flip-flop these rows and then divide this row by 2. So let's first flip-flop these. It just looks like the math might be a little bit easier. So notice when I do that the augmented matrix has to come along, or the identity matrix has to come along for the ride. So when I flip the row, I'm also flipping what's going on with the identity matrix. And then I'm focused on just whatever I have to do to get my 1 here. So what I'm going to do is I'm going to take row 1 and I'm going to divide it by 2, but I have to divide every single element in this by 2. So this becomes 1, 2, 0, and then 1/2. Okay, so now, oops. now I've got my 1. So I'm just laser focused on getting this into the 1s down the diagonal and the 0s here, okay? So let's clear some space. And so now that I have my 1 here, now I want this to be a 0, right? So I'm going to take row 2 and I'm going to add -6 times row 1 to it. Okay, so the first row, nothing's going to happen. And then the last row, this will become a 0. So then I've got -2 plus 2 times -6, which is -12. So this will be -14. And then I've got this plus, well, 0. So this will just stay a 1. And then I'm going to have 0 plus -6 times 1/2. So that's going to be -3. Okay, cool. So now I've got my 1s, I've got my 0s. This is just coming along for the ride. I'm not really worried about this right now. Okay, so next, now that I have gotten all this column all set, I need to move down the diagonal, which means that this needs to become a 1. So the only way I can really do that is just take row 2 and divide it by -14. Okay, so the first row, nothing's changing. This row will become, let's see, -1/14, and then this becomes +3/14. Okay, so now we're in the home stretch, right? So now I just need to get one more 0 right here. So I'll clear some space. Okay, so now I need to take row 1 plus -2 times row 2. Okay, so if I do that, this is going to become 1, 0. Let's see, this will become, let's see, 2/14, which is 1/7. And then if I work all that out, this will just leave me with 1/14. 1/14. Okay. And so now, okay. So here's the game that you're playing. You're doing Gauss-Jordan elimination on this side. This side is going to do whatever. It's going to go all crazy like this. And once you get this in that Gauss-Jordan form, or really this is now the identity matrix, when you get in this form, what's left over is this is the inverse. So my inverse then is going to be, so let's call this my inverse, is this crazy looking thing. And okay, so let's go back to the original problem now, because how do I know? Like, this just seems kind of crazy, right? So let's go back to the original problem. Okay, so this is where we started, and here's the inverse that we found. So you want to check that this is right. You should do this. And all you have to do is multiply the two things together. All right, so let's see. -1/14 and 3/14. Okay, so let's see. I'll show you what my calculations come out to be. So I have 6/7 minus 2/7. So that's taking, minus 2/14 plus 2/14. Okay, this is this row times this column. So 6/7 and then plus 2/14. So I'm just going to write that out for right now. And then let's see, I'm going to have 6/14 minus 6/14. So this row times this column, okay. And then let's see, this row times this column. So that's going to give me 2/7 minus 4/14. And then finally, this row times this column. And sorry, you might hear my puppy barking. So 2/14 plus 12/14. Okay, now I recommend, like, if you're catching up on this, this is worth a moment of your time to actually take a second to simplify this and believe this on your own versus just watching me do the video. So if you're trying to get caught up here, I recommend you hit pause and get caught up and work out the final answer and then hit play. Okay, so if I work this out, the way that these fractions simplify is 1, 0, 0, and 1. Ta-da! We found the right inverse. So you will totally get sometimes some crazy looking fractions with these inverses. And so this is why it's kind of worthwhile, because you lose this sense of like, what am I doing? Is this right? I don't know what's going on. Multiply them together. If you get back to the identity matrix, you have found the right inverse. Okay, now what fun would it be if we didn't do a 3x3 matrix? I know you're so excited about this, right? Okay, so first things first, I'll walk you through this, okay? So why don't you set up the augmented matrix first? You do that and then hit play when you think you've got it. Okay, I'm gonna go ahead and just pop the augmented matrix on screen. Okay, there we go. Boop. All right, so now we want to turn this side into the identity matrix, really just using the Gauss-Jordan method. So I'll get you started on this. So let me make some space. Okay, so looking at this, I think that, well, we've got a 1 here, so probably the path of least resistance, right, would be to just flip the rows. So let's see, that's going to give me 1, -1, 1. Don't forget the other side, 0, 1, 0. And then 3, 1, 2, 1, 0, 0. 2, 1, -1, 0, 0, 1. Okay, so what I recommend, just to give you some space to think about this on your own, I recommend that you now use this one to get your other 2 zeros and then hit play and just double check where you're at, as you know, so we'll just have a few checkpoints in here, but I think that this is worth your time to try this on your own. So you get the other 2 zeros in the column and then hit play when you want to check, okay? And I'll see you there. All right, so let's see. I need to take row 2 plus -3 times row 1. So I'm just going to write the result of that, just in the hope of keeping this video shorter. So let me just show you what my math comes out to. Okay, so here's the result of that calculation. And then I also need to take row 3 plus -2 times row 1. Okay, so now you can check your matrix work against mine. So I think this is the way that this is like the best way to approach this. This gives you some space to work on this, but also we can catch any errors, since I'm sure you know by this point that it's very easy to make an error with these types of problems. Okay, so I have my 1 and my zeros. So, you know, Gauss-Jordan method, you know, trying to get the identity matrix, we're just going to move down the diagonal and try to get a 1 here. And thankfully, I can actually use this row to do that, right? So I could just take row 2 plus -1 times row 3. So I'm effectively just subtracting the row, right? So that's probably the path of least resistance to get a 1 here. I'm just trying to avoid getting any fractions if I can. So let's clear some space. And then just in the interest of time, so I'm going to go ahead and just do that calculation and flash it on screen. So what I would suggest is that you take the time to do that calculation and then check your work against mine. I know it can be tempting to watch a video like this and to just be like, I don't want to do that because, you know, these take forever. But part of doing this is learning to get accurate, and so it's very important that you actually take the time by yourself to try this and make sure that you are being accurate, because if you're not, that's an important thing to know about yourself, and it's good to figure that out while you're watching a video where we have these little stop checks versus getting super frustrated on your homework because you don't know why you're getting it wrong. So I highly recommend pause here, just do the next part of the calculation and hit play when you're ready to see it. Okay, so with that warning in mind, now I'm going to show you the result of this calculation. Okay, so you can pause here and just double check your work against mine. And once you're good on that, now we need to get zeros in the rest of the column. So I need a 0 here and a 0 here. So once again, I recommend that, you know, you pause here, try to get your zeros, really try to strive for accuracy, slowing down, all that good stuff. Hit play when you're ready. Okay, so I'm going to do both of these transformations at once. So I'm going to take row 1 plus row 2. I don't have to do anything to row 2. And then this row, to get the 0 here, I need to take row 3, and then I need to add -3 times row 2 to it. So I'm going to do both of these just transformations at once, and then you can just check where your matrix is against mine, and then you can see if you have any errors. So I'll clear some space. And now I will show you the results of the calculations. Okay, So I'd say pause here, just double check that your matrix matches mine, and then we can keep going. Okay, so now I've got my zeros, go down the diagonal. I need this to be a 1, so to get a 1 there, I'm going to take row 3 and I'll divide it by -9. So why don't you go ahead and do that, and maybe just try to finish this and then hit play when you think you've got it finished. Okay, so I'll show you the result of dividing by -9. So let me clear some space. And then I'll show you the result of that calculation. Okay, so I just simplified the fractions, and so this is where I'm at. And so then to finish this, so now what I need to do is I need to take row 1 plus -3 times row 3, and I need to take row 2 plus -2 times row 2. So I'll just do both of those at once so you can see what the final matrix is. So I'll make some space. And now I'll just show you the result of the last 2 transformations. Whew, okay, cool. So here is what you should have. Double check. And, you know, if it took you a little bit to get there, you know, you found you made an error here or there. I mean, I'll be honest with you, like making this video, I made errors too. It is very common. You have to be very, very precise. And that's a skill. I think a lot of people just think, oh, it's like some sort of natural ability, or it's not. It's not a natural ability. It is something that you have to really practice and learn. And, you know, I only do this now. You know, I haven't done this in a couple of years, to be honest with you. So even just me doing it, I've lost a degree of my accuracy on this just because I'm out of practice. And when I was a student, I had to practice this a lot, and I got very, very used to being super, super accurate. So if you're a little frustrated and saying, oh gosh, this is going to take forever, it is, I promise you, it's all practice, patience. It's a real skill, and it is something that is a very good skill to have, to be honest with you. Okay, so I've got this. This should be, in theory, my inverse. So let's go back to the original problem and let's check it. Okay, so now what I'm going to do is I'm going to multiply this times this inverse that we just found. So I'm going to go ahead and just, actually let me get rid of this notation here, and I will just multiply these together and we will just check. So I will show you the results of my calculations. Once again, you know, I think it's best for you if you pause here and you give this a try and then just see if your calculations match mine. Okay, so I'm going to show you what it is to multiply this row by this row. I'll just show you the resulting calculation. So if I multiply this row by this column, here's my calculation. Now I'll do this row times this column and this row by this column. So we'll just check how your calculations look at each point. So let me do those. So check it out. Here is taking this row by each column. So if you just want to check your math against mine. Okay, so let me show you that again now. I'll take this row times each one of these columns. So again, if you want to just kind of work that out and then check your math against mine, that would be a good way to do this problem. Okay, so I took each one of these times each one of these columns. So here's the calculations, and now I'll take the last row times each column and just show you the work for that. Okay, so there are all the fractions that I have, and I mean, I'm a nerd, I get it, but I always got a sense of wonder about doing this because this just seems kind of like a bunch of crazy fractions, right? So if I clear a little space and I take each one of these wild looking calculations, so I get 1, next one comes out to 0 and 0. That is crazy. And then this is 0, 1, 0. And you can take your calculator and just check all of these, as you should. I did. This actually works out to exactly what we needed. I think this is just crazy that, like, I don't know, humans figured this out. This is so interesting. It looks like this shouldn't work out. It just seems like such a crazy set of numbers, but it totally works out. So we found the right inverse. Okay, so I have one more I want to talk to you about. What happens, what happens when a matrix doesn't have an inverse? This is actually a pretty simple example. Okay, so I ask you to find the inverse of this. You might already have a hint as to why this won't have an inverse, but let's set up the augmented matrix, and then we can get the party started. So there's no great way to do this, so I'll just take row 1 divided by row 3, so I'll make a little space. and just in the interest of time, so I'll show you the result of doing that calculation. Okay, so I got my 1. Now I got to get a 0 here, so I'll take row 2 plus -6 times row 1. So I'll just show you the result of that calculation. Again, I would recommend that you just do it on your own. So here's the result of doing that calculation, and you probably see the issue with this now. We have 0, 0. And so when that happens, that means there is no inverse. That will just pop up from time to time, so just wanted to make sure you knew how to read that result. So this particular matrix doesn't have an inverse because we got this 0, 0. And I think this video is probably long enough, don't you? So I guess we'll leave it there, and I will catch you guys in another video.